In the world of AI, it feels like we might be at a real turning point. For the longest time, one big question has been hanging in the air. Can open source models ever really compete with the closed source giants? Well, a new paper from the team at DeepSeek might have just dropped the mic with a massive yes. Let's get into it and see how they pulled it off.
For a while now, it's really felt like a one-sided race, hasn't it? The big proprietary models from the huge tech labs have been getting better at this incredible breakneck speed, and the open source community, while doing amazing work, seem to be falling further and further behind. This wasn't just a hunch. The paper says this performance gap was getting wider every day.
So in this explainer, here's what we're going to do. First, we'll look at why that open source gap exists in the first place. Then, we'll dive into the 3 brilliant innovations DeepSeek came up with to bridge it. We'll see how their new model, V3.2, stacks up in the real world. Then, we get to the really wild part, a special version of the model with some jaw-dropping results. And finally, we'll ask the big question. What does this all mean for the future of OpenAI?
All right, so let's start at the beginning. We need to really understand the core problem that the DeepSeek-V3.2 model was designed to fix.
Now, it's not like open source models weren't improving. They absolutely were. But what the paper highlights is this distinct divergence. It's like both were climbing a mountain, but the proprietary models suddenly found a rocket ship, especially when it came to really complex, multi-step thinking. So what was going on? What was causing this divide?
The researchers really nailed it down to 3 critical weaknesses. First up, the basic architecture. Most models were using these traditional attention mechanisms that just get bogged down. They're slow and super expensive when you feed them long texts. Second, a resource gap. Not enough computer power was being put into refining the models after their first round of training. And third, they just weren't very good agents. They had a hard time following a series of complex instructions to get something done.
So, to tackle these 3 big problems, the DeepSeek team did something really smart. They didn't just build a bigger model. They came up with 3 incredibly clever innovations that completely changed the game. To fix that inefficient architecture, they invented something called DeepSeek Sparse Attention, or DSA. To close that resource gap, they figured out a new way to do scalable reinforcement learning. And to build better agents, they created a whole new pipeline for generating massive amounts of training data. See? Each solution is a direct answer to one of those weaknesses we just talked about. Let's dig into that first one, DSA, because this is a huge deal for making AI more efficient. So, think of a normal AI model as a librarian who, to answer your question, has to read every single book in the library, cover to cover. It works, but man, is it slow and expensive. DSA is like a superpowered librarian. You ask a question, and it instantly knows the exact 3 pages in the entire library that hold the answer, reads just those, and you're done. This makes the model unbelievably faster and cheaper.
Okay, so we've got these cool ideas, right? The smart librarian, better training. But the big question is, how does it all translate into actual performance? Well, this is where the story gets really exciting.
Check this out. On a really tough benchmark for advanced math, DeepSeek V3.2 hits an incredible 93.1. Just look where that puts it. It's right there, neck and neck, with the estimated scores for giants like GPT-5 and Gemini 3.0 Pro. This isn't just about closing the gap anymore. This is about showing up to the championship and competing head-to-head.
But wait, here comes the knockout punch. Remember that super fast librarian, the DSA architecture? Well, because of that, it gets this top-tier performance for way, way less money. The older DeepSeek model costs more than $2 to process 1 million tokens of long text. V3.2, it brings that cost down to under $1. That is almost 3 times cheaper. For anyone who actually wants to use this stuff at scale, that is a massive, game-changing difference.
As amazing as all that is, the team wanted to see what would happen if they just took the gloves off, pushed their creation to the absolute limit. And that led to an experimental version they call DeepSeek V3.2 Speciale. See, the standard V3.2 model is built for that balance of performance and efficiency, but the team asked a crazy question. What if we just forgot about efficiency for a second? What if we let this model think for as long as it needed, using all the computing power it wanted to solve some of the hardest problems on the planet? And the results, they are just astounding. With no special training for these specific contests, this general-purpose AI won gold medals. Not one, but across the board. The International Mathematical Olympiad, the International Olympiad in Informatics for Coding, and the ICPC World Finals for Programming. Let's be crystal clear here.
These are the world championships for the smartest young humans on Earth, and an open-source AI just showed up and won gold in all three.
So, wow, a gold medal-winning open-source model. What in the world does a breakthrough like this actually mean for the future of artificial intelligence?
Well, this paper basically hands us a blueprint. First, being smart about your architecture is everything. It unlocks both performance and affordability. Second, that post-training phase is absolutely non-negotiable. You have to invest serious compute power to refine the model's judgment. Think of it like sending your AI to grad school. And third, if you want to build AIs that can actually do things, you need to create this huge virtual playground for them to practice on.
And this chart just proves that last point so powerfully. See the dotted lines down at the bottom? That's the model's ability without all that special agent training. Now look at that solid blue line just rocketing upwards. That's the same model after practicing on thousands of those custom-made tasks. Its ability to handle brand new real-world problems just goes through the roof. This is how you build a truly capable AI.
Now, of course, the work is never finished, and to their credit, the researchers are really honest about the model's current limits. It still needs a broader base of world knowledge, and that gold medal speciale version, it has to think for a really long time to get those amazing results, so it's not very efficient. These are just the next mountains they have to climb.
So, this all brings us right back to where we started. For the very first time, we have an open-source model that hasn't just caught up to its closed-source rivals. In some of the world's most difficult intellectual arenas, it has actually surpassed them. So, is this the moment the tide finally turns? Is the era where only a few big companies have the best AI coming to an end? The story's not over, but the race just got a whole lot more interesting.